Hello, everybody. I realize that we are running behind schedule, so I'm cutting into lunchtime, so I shall endeavor to be as brief as possible. So, hello, I'm Arto from Finland, these days living in Dubai, in the United Arab Emirates, where I founded my latest startup, my third Haltia.AI last year. And as you probably have heard, in the UAE, the government is very supportive of AI, so it's a great place to be. There are also several very good research institutes over there. So I'm here today as a representative of the dark side, right? The pull of industry, and otherwise known as applied research. Let me tell you a little bit about something very different from what we've heard so far in the three keynotes this morning. I have nothing to do with image processing or computer vision, but I do know something about symbolic AI and how to combine that with large language models and generative AI. So we are building a platform called Asimov. Asimov is a platform that can be delivered in multiple different ways. One of the things we are working on for consumers, for individuals like all of us, is an application that is a personal AI. Now, you might think it looks just like ChatGPT, or it looks like any one of the 1,000 competitors out there, but there's a very big difference. Just like in the keynote by Professor Zhu, I believe it was earlier today, we actually have a quantized model running directly on your phone. This is a trustworthy personal AI, meaning there's no data sent to the cloud that you don't approve. Your conversation history is not shared with American companies in Silicon Valley. So this is something which is in closed beta, and I'd be happy to give access to anybody who thinks that this could be useful to you in your personal life or your work life. Obviously, for personal AI to be useful, it needs to have more than chatbot functionality. We have integrations with a ton of everything, including the obvious ones like sending email and managing your calendar and so on and so forth. So what is this actually under the hood? Well, to the old-timers here, it should be pretty clear. This is a neurosymbolic AI. This is the combination of neural networks, so in this case, transformers-based large language models, with symbolic AI, in the, let's say, the semantic web incarnation. So we have a graph database on the phone, which is storing captured facts represented as triples, subject, predicate, object. Then we are combining this with the large language model, meaning that we are capturing knowledge from the conversation history with the user, and we are also feeding appropriate knowledge into the context window when the user interacts with the system. So this is neurosymbolic AI. We are finding it very promising in terms of working around the deficiencies in LLMs. I think 3 years into the LLM revolution, generative AI revolution, is becoming clear that there are strict limitations what LLMs can achieve beyond demo cases, meaning they hallucinate a whole lot, they are very static, it's difficult to update their knowledge. They have other deficiencies that can be addressed by a hybrid system. So this is a hybrid system, neurosymbolic. On the other hand, the hybrid also goes the other way. So symbolic AI failed in the 1980s, late 1980s, early 1990s, leading into an AI winter because the common sense problem. Right? So expert systems were very useful in particular domains like medicine, but they just couldn't handle the real world beyond the confines of the clinic, because they don't know anything about the world, things that my 3-year-old knows. So now with LLMs, this problem of tacit knowledge seems to be somewhat handled, at least. Maybe not solved, but somewhat handled. So instead of decades-long projects like CYC, that's also known as OpenPsych, Research Psych, that run for 40 years trying to capture and encode all of the knowledge, tacit knowledge, implicit knowledge that we have as humans, capture that into symbolic form, and well, they're still at it. LLMs have, through the pre-training, captured a whole lot of relationships about the world. They know that the arrow of gravity points downwards, they know why the sky is blue, they can explain to you that humans prefer to live in dwellings, they can talk about the social structure of human society. All of these things that were very difficult to encode as factual knowledge, LLMs nicely complement symbolic AI. So that's the neurosymbolic synthesis. We're having good results with that. We have currently research collaborations around the world. I'm here looking for more. I'm very happy to discuss very, very interesting use cases that we have in the UAE in particular, but not only in the UAE. We believe ultimately that this will be the way to, in the next few years, that the industry is going to evolve as the limitations of LLM only, LLM plus RAG, retrieval augmented generation, these limitations are becoming clearer and clearer to everybody, and I believe that the next thing there is knowledge graphs. So academia already knows this, industry isn't quite so aware generally, still stuck in the RAG stage. Another thing I want to bring to your attention is that we are in an extremely fast-moving field. This is probably, there's nothing else like it. Even a year ago, there were something like 4,000 papers, AI plus ML papers published on arXiv every month. So more than 100 a day. And that's actually on an exponential curve. So it's probably a whole lot more by today, but I don't have the figure right now off the top of my head. What it means is that none of us has any chance of keeping up. US researchers, and certainly not poor little me in the industry, a little bit further removed from the research pipeline usually. This means that it's very, very important, especially for a startup like mine, but potentially for you as well as researchers, to be able to keep up, meaning to be able to adapt, to be able to take on new innovations quickly. For example, as I go to some of these conferences, I'm struck by papers being published about utilizing Llama, as in Llama 1 or Llama 2. I'm happy that in the roster today, we have 69 papers. Of those, a handful are LLM papers, and they're all using Llama 3, which came out not that long ago. So good job on whoever updated the paper very quickly and adapted. But especially for a startup, to be able to be relevant in an absolutely saturated market, you cannot imagine how competitive it is out there. There's hundreds of new AI startups being founded every day. In order to remain relevant at all, it's very, very important to hit on some way of assimilating new innovations very quickly into what we are doing. And we have hit on such a way. This is a concept much like knowledge graphs, or symbolic AI as it used to be known. It's very old. It was considered to have failed in the industry for decades, but I find that it's often very good to go back into history to find hidden gems that they were just before their time, and now their time might have come. As we have seen in the last decade with neural networks, after they failed for decades until hardware caught up, as we are seeing now with knowledge graphs. So this idea, this big idea, that allows us to keep up with the industry is called flow-based programming, FBP. I heard another meaning for FBP today, but this is something I suggest might be interesting to look into for those of you who are more on the, let's say, the software engineering angle. As a system architecture, this was invented in the 1960s at IBM, and ever since then it's been a minority position against the von Neumann paradigm that dominates our industry. But I think AI might make it relevant again, just like it's making knowledge graphs relevant again. And by the way, I was a knowledge graph founder already in 2010, and it was a hard job selling those things back then. It was a hard job explaining symbolic AI. Now it's a lot easier. LLMs really made the difference. What is flow-based programming? Well, it's the idea that why don't we treat software fundamentally the same way as we treat electronics? Why don't we actually make things into reusable components and hook them up with external wires, basically, connections. And in this way, you can assimilate any innovation in the field very, very quickly, and you're also building in a way that's very robust and easy to change, adaptable to change. So this is maybe the most important innovation that we are deploying as compared to the competition. Now, the platform I'm describing is available in open source form. Parts of it are already open source. The rest will be open source soon in the next few weeks. One aspect that might be of interest in case somebody is working with knowledge representation is our ontology called KNOW. It's a bit of a difficult name in English, but it just means KNOW, meaning Knowledge Navigator Ontology for the World. And as far as I know, this is the only current ontology that's actually dealing with real-world use cases, everyday use cases, meaning that we represent the mundane. Nothing exciting, nothing academically exciting there. But what we need for the neurosymbolic use cases is exactly the mundane. We need to represent family relationships. We need to represent people's wants and desires. We've actually, to cut down the scope of this a little bit, we've started out with only the human universals, meaning space-time plus social. That's a good initial scope for the project, large enough. And of course, we are using generative AI also in the ontology development so that it feeds back up on itself. So if any of these things sound interesting to you, come talk to me. Happy to give you beta access to the personal AI application for your own use, and happy to give you early access to the Asimo platform, as we are calling it, which I do believe it would be useful in many of your research, and we can discuss that in detail one-on-one. So that's all. Let's have lunch. Thank you for your attention.